Alright, so this is exercise 20D, question 16. And we've got a shaft AB that is 30 centimetres long. Now I haven't labelled that yet, so let's label that. That's 30 centimetres there. And it's attached to a flywheel, so the flywheel's spinning round and round. You can see the direction of the arrow there. It's going in a clockwise direction. So it's spinning that way. Alright, now B is going to slide along backwards and forwards along OX there. The radius of the wheel is 15. And the wheel rotates clockwise at 100 revolutions per second. That's pretty quickly. Find the rate of change of ABOs, that's of theta, when angle alpha is equal to 120 and 180 degrees. So, what's our goal? We better make a note of that. Remember, that's always what we want to do first. Our goal is to find d theta dt. Now, what rate do we know? Because remember, you have to know. Oh, there's something on the screen there. That's why I'm sliding it all to the side there. I'll put that back. We need to know a particular rate before we can find the rate that relates it to give us our goal rate. So we know that the rotation here is 100 revolutions per second. So I could find the change in the angle alpha in terms of t. That's what that's giving me. So the alpha dt. So in 1 second, that angle is going to spin around 100 times. Every time it does 1 revolution, that's 2 pi. So 100 revolutions, that's 200 pi. But we're going in a negative direction. So alpha is changing by negative 200 pi radians per second. So that's the rate we've got. So what's the rule that's going to relate them? d theta dt is going to be, I've got a d alpha dt, what's the one I need? I need a d theta on top and a d alpha on the bottom. So I need to find a rule that's going to relate theta and alpha. And looking at our triangle there, we've seen what we've got opposite pairs there. I think it's pretty obvious that we're going to need the sine rule here. So if I want to find d theta d alpha, I need a rule relating the two. So I've got sine alpha over 30 is equal to sine theta divided by 15. Now, what's my next problem here? If I try and multiply, well, I'll multiply through by 30. Let's get rid of those denominators first, just because that's going to help us a little bit. So I'm going to multiply through by 30. So it'll look a little bit nicer before we ponder our next conundrum. This is going to be sine of alpha equals 2 sine theta. Now, ideally what we'd like to do is we'd like to divide by 2 and do arc sine. So we'd have arc sine of a half sine alpha. You don't want to be differentiating that. We haven't dealt with things like that. So we're going to have to think of another technique we have that's going to enable me to get d theta d alpha. And if you remember back to our implicit differentiation, I could just find the derivative in terms of alpha of each side. And I'm writing that on the right there, but usually you'd write it on the left if you had some space. If I do that on the left-hand side, the derivative of sine alpha in terms of alpha, well, that's just cosine alpha. That's not too bad. The derivative of 2 sine theta in terms of alpha. Well, I could do the derivative in terms of theta, so 2 sine theta, and then multiply that by d theta d alpha. That's the implicit differentiation using our chain rule. And look, we've got what we wanted there. We've got the d theta d alpha. So now I've got cosine alpha equals the derivative of 2 sine theta in terms of theta is 2 cosine theta by d theta d alpha. So d theta d alpha, I just divide by 2 cos theta, so I'd have cosine alpha divided by 2 cosine theta. Alright, so you'd think we'd be on the right track here now, so I can go back up to my d theta dt and substitute in what we know. So d theta dt is going to equal d theta d alpha, which we now know is cosine alpha over 2 cosine theta. And that's multiplied by d alpha dt, which is just negative 200 pi radians per second. So we simplify that, 2 divides into each one, and we've got negative 100 pi cosine alpha divided by cosine theta. I don't need that 2 anymore. So that's pretty good. Now we've got to substitute in theta alpha equaling 120. And we might find a little bit of a challenge here. If we have a look, d theta dt, when alpha equals 120 degrees, is going to give me negative 100 pi cosine 120 degrees divided by cosine of theta. I've still got this problem that I don't actually know what cosine theta is. And we're going to need to do a little bit of clever work here to figure out what cosine theta is. And what we need to do is we need to come back to that rule that we had that related alpha and theta. Now, I know that alpha is going to be 120 degrees, so I could replace that in here. And actually the second one down is probably even easier. Sine alpha equals 2 sine theta. So let's go and do that. So we know that alpha is 120 degrees, so that would imply that the sine of alpha would equal 2 sine theta. We're going with that, so sine 120 degrees equals 2 sine theta. Sine of 120, best friend in maths, unit circle. There it is, that's 60 degrees away from the x-axis. It's positive in that quadrant. What's the sine of 60 degrees? 1, 2, root 3. So that's going to be root 3 over 2 equals 2 sine theta. Dividing by 2, root 3 over 4 equals sine theta. So we can now work out cosine theta. Two ways you can do that. You could do arc sine of root 3 on 4, substitute it in and work out the angle. Or I like to do this one by, if sine of theta is root 3 on 4, let's let this one here be theta. Opposite would be root 3, hypotenuse would be 4. If you want to know the cosine, all I need to do is figure out this side. Bit of Pythagoras Theorem, 4 squared plus root, or equals root 3 squared plus, well, let's call that L for one. There you go, L squared. 16 equals 3 plus L squared. 13 equals L squared. Root 13 equals L. So this side here is root 13. So therefore cosine of theta equals root 13 over 4. And I can now substitute that in. Up into this d theta dt calculation, we'll actually get the answer. So I've got negative 100 pi cosine of 120 is the same as negative cosine 60, so that's negative 1/2 divided by root 13 over 4. Negative 1/2 by negative 100 becomes 50 pi divided by root 13 on 4 is multiplied by 4 on root 13. So I've got 200 pi divided by root 13, and that would be radians per second. So the angle would be increasing. If we look at our diagram, as that moves clockwise, the flywheel is going to come further out here. Yeah, that sort of makes sense that that angle would be increasing. That's not too bad. So we've got 200 pi on root 13. That's the way the book has it. You, of course, we'll do the right thing and call it 200 pi root 13 over 13 radians per second. And there we go, we've already got the answer that we're looking for. Part B, nice and easy. What happens when we would need d theta dt and alpha is equal to 180 degrees? Well, if you have a look at the diagram, when alpha is 180 degrees, when alpha is around there, well, theta is going to be 0. That's actually going to be really easy to calculate. So we're going to have, where's my expression again, negative 100 pi, negative 100 pi cosine alpha divided by cosine theta. So cosine 180 degrees divided by cosine 0 degrees. Negative 100 pi, cosine of 180 is negative 1, cosine of 0 is 1, so this is just 100 pi radians per second. And there you have it. I hope that helps. Cheers.